So, first of all, what is given? What is 8 feet per second? Can anyone tell us, what do you think is 8 feet per second in our picture? Rate of change of? Right? It's this distance. The rate of change of x with respect to time. Okay, what are we asked to determine? What are we asked to determine when 200 feet of string has been let out?
D theta over dt.
Excellent. D theta over dt. Great job. Good. So obviously I need an equation that involves theta. Is there an equation that I can come up with that involves theta and of course W? And X. A trig function indeed. It could be that I don't have to involve W because I still have to involve W somehow, but I could use tangent, which is the opposite over the adjacent. So I could write tangent theta equals 100 divided by X. I will differentiate implicitly. I differentiate the left, and I differentiate the right. I just want to refresh our memory. Do we remember 1 over x prime? What does that equal to quickly, so we don't have to perform that moving forward?
Elements.
Negative? You're right, but it's in chapter 5, it's the integration, but you're right. So when we differentiate this, we get negative 1 over x squared. Let's do it. Maybe we don't have to do it again. Prime. We bring negative 1 in front and we subtract 1 from the power, and that's how we get the negative 1 over x squared. So the left-hand side, can anyone give us the derivative of the left-hand side? We know the right-hand side is this. Done. Times dx over dt, of course. But the left-hand side, can anyone give us the derivative? So this is an equation I forgot to write, but I think moving forward it's clear. It's an equation that has two functions of time, theta and x. So the left-hand side, can anyone help with the left-hand side? So it's secant squared, but that's not enough. Very good. Indeed, times d theta over dt. Great job. And now let's see if we have everything. So this is my variable. That's what I'm interested in. I will divide both sides by secant squared. I don't have theta. I do have dx over dt. But I know that w is 200. So I still have some calculations to perform, but that's okay. So let's solve for d theta over dt first. So d theta over dt will be negative 100 over x squared secant squared theta times dx over dt. Okay, and this is when w equals 200 feet. Okay, fine. So I do have this. It was given to us as 8 feet per second. I do have w, which is 200, and this is 100. So that will give us theta, and will also give us x. So theta, sine theta is 1 over 2. What could theta be if sine is 1 over 2? Opposite over the hypotenuse. There's only one angle that has, in the first quadrant, that has sine 1/2.
Over 6.
Yes. So theta is pi over 6. So I will be able to determine this with no difficulty. And in order to determine x, I have 100, I have 200, I can determine x. 200 squared equals x squared plus 100 squared. The hypotenuse squared is the sum of the legs squared. I move 100 to the other side. 200 squared minus 100 squared equals x squared, or x squared equals, the way I like to do this is 200 minus 100, which is 100, and 200 plus 100, which is 300. But it doesn't matter how you want to do it. I use the difference of squares. That's easier because sometimes I'm lazy with the calculator. So this is 100 times 300. So 300 and 2 zeros. So that's the answer here. But that's not the answer for x. The answer for x will be 100 the square root of 3. So x equals 100 the square root of 3. Yeah, I don't need 2 because it's x squared anyway. So I don't really need to take the square root. Okay, finally we are ready to finalize this and get the final number. So d theta over dt is negative 100 over 30,000 multiplied by, okay, secant is 1 over cosine. So we know that cosine theta is the square root of 3 over 2. And when we square cosine theta, we have a secant square theta, which will be 3 over 4. So this is 3 over 4. I should put 4 at the top, but that's okay, so you can see it. Okay, so finally, d theta over dt is 32 when I flip this, 32 and 2 zeros, and this is 9 and 4 zeros. 2 zeros go away, and I divide 32 by 900. 32 divided by 900 is negative 0.0355 with a period. Without the measurement unit, makes no sense. Careful. What do we measure theta in? What do we measure time in? And that will be the measurement unit for this. What do we measure theta in? Radians. And the time was in seconds. So the more string we allow, the smaller the angle becomes. And when the string has a length of 200 feet, at that instant, the angle changes, decreases to be exact, by 0.0355 radians per second. At that moment, at that instant. Any questions? Anyone, any questions on this problem? let's move on to another type. Something like, here it is. We have a spotlight on the ground. And here's a wall. And here's a person. Forgive me, I cannot draw a person. Walking towards the wall. Okay, so this person maybe started here. Well, we don't care where it started. But when he was here, let's say, here is the shadow on the wall. When he's here, the shadow on the wall is this high. When he is here, look what happens. The shadow on the wall is even smaller. So as he walks away from the spotlight to the wall, his shadow on the wall is decreasing from, I don't know, whatever, let's say from this point till this point, from this height till this height, and so on and so forth. Okay, so now let's read the question. A spotlight on the ground shines on a wall 12 meters away. Fine. If a man 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second, and you'll tell me what this is in a minute. How fast is the shadow on the building, on the wall? Decreasing. When he is 4 meters from the building. So that's our question. How fast is the shadow on the wall decreasing when he is 4 meters from the building? We have to first identify what this is. Then I have to use some notations. Maybe I should just, I don't want to give it the impression that is the height of the wall, because it's not connected to that. Okay. So, what is this? And what am I asked to determine? And remember, anything that follows after the word when, later. Much later. Okay. So, what is 1.6 meters per second?
dx/dt.
Great job. Perfect. What am I asked to determine? Very good. dy over dt is what I'm asked to determine, keeping in mind it has to be a negative rate. If it isn't, I messed up something, I have to go back to the drawing board. Okay. So I have to find a relationship between what I'm asked and what I'm given. I'm given this person's height, I'm given x, and I have to find y. I have to find an equation that involves what is given and what I'm asked to find. So I'm going to take all that picture out of there because I need to explain what we're looking at. So that's the light. Here's the person moving. Here's our y. Here's our 2. Here's our x. And here's our 12. This is what I have. So does this trigger anything? Does this mean anything to you when you see something like this? And I can give one more hint. Of course, these are right triangles. Not this time. Not yet. So I'm looking at the green triangle and the pink triangle.
Is it similar triangles? Or
Thank you very much. Thank you very much. This is the symbol for similar triangles. So the green triangle is similar to the pink triangle. I have to show why, and then I have to show what happens. Why I even think of this. Okay. So here's why. I have to show two, we call it them congruent. Fancy word for equal. It means more than just equal, but so I have to show two congruent pairs of angles. Then I can conclude similar triangles. If I cannot show two, what about three? Well, if I have two, the third pair has to be the same. So I have to show two congruent pairs of angles. Oh yeah, no problem. First of all, they are both right triangles. So two angles are the same. And this is a common angle. So this is common angle. So if two triangles have a common angle and they have another pair of equal angles, they are similar. There is no discussion. Okay, brilliant, but what do I do with this? Well, similar triangles have a huge property that we need to use right now. Let me see how with time, 17 minutes, that's fine. Okay, property of similar triangles. We can write proportions, three to be exact, three fractions, two proportions, three proportions you can consider, with their sides, with the measure of their sides, of course. And that's why this is huge. But how do I write them is extremely important. I cannot just dump some sides in there. So here's how we write them. All the top ones have to come from the same triangle. All the denominator ones have to come from the same triangle in a specific, clear order. I will start, so I will write the top, small. And the bottom, small triangle, big triangle. I start with the common angle. Common angle has an opposite side, which is 2. The same angle has an opposite side in the big triangle, which is y. I move on to the right triangle, but I don't know this and I don't know this, so I'll skip. I move on to the last one, which has to be the same. There is no doubt about it. The opposite of this angle in the small triangle is x. I go to the big triangle. The opposite of the same angle in the big triangle is 12. This is a proportion I need. Cross multiply xy equals 24. This is what I need. It's the relationship that connects what I'm given to what I'm asked to determine. Good. I will differentiate implicitly, knowing that there are two functions of time here, and they have to be treated as functions. X is a function of time